When we do redistribution in the context of EIGRP, if we're redistributing from another EIGRP process, the metrics associated with that process are actually redistributed into the EIGRP process where we actually did the redistribution. If we use a static route, that's actually going to also be involved because it's going to take the prefix information associated with that static route. In any other instance, we need to be able to specify a metric, a seed metric that we want to be able to use. You guys have seen me use the 5 ones as my seed metric a number of times. And what I want to do here is I want to illustrate the fact that we have the option of being able to go under a process and dictate what that metric is going to be using a value called the default dash metric. So default dash metric. Now what I want to do is I'm going to show first of all how to do it in classic EIGRP mode. So what we'll do is once here, all I'll do is I'll go to config T router EIGRP 10, and what I'm going to do is I'm going to say default dash metric. And I'm going to say, well, what is going to be the default kilobits? Let's say 1500. Then what's going to be the delay in tens of microseconds? Let's say 1000. What's going to be the reliability? Let's say 255. What's going to be the effective bandwidth, the load, where 255 is maximum? Let's say 1. Then what we're going to end up doing is we're going to say the maximum transmittable unit. We'll just leave that at 1500. And that's it. Now what we're going to do is let's create a prefix. Let's say IP route, and let's say I want to IP route, let's see, we'll say 22, 22, 22, 22. And I'm going to say match that exactly. And what am I going to do? I'm going to say null 0. So do show IP route. What are we going to see here? We should see a static route in here for null 0, for 222, which we do. Now that's not being propagated because it's not participating in EIGRP. Let's change that. Router EIGRP 10, redistribute, connected, not connected, static. Now the moment I do that, I can specify a seed metric, or I can rely on the default metric that I just configured. All I'm going to do is press enter. Now what I'm going to do is I'm going to come in here and I'm going to say show IP EIGRP topology table, and I want to look at 22.22.22.22/32. And what am I going to see? I'm going to see 1500 kilobits. I'm going to see 10,000 microseconds. We entered it in thousands. I'm going to see a reliability of 255. I'm going to see a load of 1. I'm going to see a minimum MTU of 1500. And notice I have a hop count, and since it was redistribution was taking place, I was doing the redistribution on the device R22, and it's giving me the highest IP address that it's using for the router ID. Now that's another thing we're going to talk about shortly, but what I'm going to do right here is if I scroll up, what we're going to see here is this is going to be, let's see, where is it? We have the entry. There's my router ID. 172.16.223.222. Now, let's go over and take a look at named operations. So we'll go over to R21, and here what I'm going to do is I'm going to create another prefix. I'm going to say config T IP route. Let's create a default route. And let's go ahead and just send it to null 0 also. Now what we're going to do is I need to go to my router EIGRP named config, and under my name config I need to go to address family for my IPv4 unicast traffic and autonomous system 10. And what am I going to do? Here I'm going to go to my topology base, and this is going to be where I have the capability of defining my default dash metric. And now what I'm going to say is, let's say this is going to be 10,000 kilobits. We will say 2,000 microseconds. We will say it's 100% reliable. We will say there's no load, well, hardly any load. And I'm going to say my maximum transmittable unit is going to be 1500. Now what I'm going to do is I'm going to say redistribute static, and I'm not going to specify any other values. Now what I'm going to do is I'm going to say do show IP EIGRP topology table for 0000/0. And what am I going to see? I'm going to see the 10,000 kilobits we entered. Notice it's converting my tens of microseconds into picoseconds because this is operating in named mode. 100% reliable, hardly any load, 1500 is my maximum transmittable unit size. Now, this is going to actually create, excuse me, this is actually going to create a default route in my environment. Let's go over to R22 and say show IP route. And what am I going to see? I'm going to see an external prefix for my default route, my static default, and it's going to be actually selected as my gateway of last resort. Now, the other part of this is that when we go into it, the main goal here is to recognize the fact that EIGRP has a problem here. This is the problem. First and foremost, let's talk about router IDs. Router IDs. Now, a router ID, we saw that we can see where a particular prefix was originated from. So let's take a look at what's going on R22 with regard to this default route that we have. Excuse me. Show IP EIGRP topology for 0.0.0/0. All right, now we're going to load share to reach it, but the main thing that I want to focus on here is the originating router was 172.16.20.20. So we know it originated on this particular device, and what's happened is the highest loopback address has been selected as the router ID. So the RID for EIGRP is made visible by virtue of the fact that I use my show topology table, show IP EIGRP topology, and it's going to give me my router ID. Well, this is the router ID where this prefix was originated. The local router ID on R22 we see is going to be 172.16.223.222. Now, what we want to play around here with is the fact that, remember, what happened is R22 originated this prefix. This prefix right here was advertised into the network by R20, and that prefix said it was originated by this device using that IP address of 172.16.2020. Now, what the problem here is that how does EIGRP know that this prefix is not routed or is not looped? So what's going to end up happening is the EIGRP has a loop prevention mechanism embedded in it that says if I learn about an external prefix, which means it's being redistributed on another device, and that device has the same router ID as me, I know it's been looped back to me, so I'm not going to place it in my routing table. Let's look at this process right now, because what I want to do is I'm going to go in here and I want to change the configuration on R20 and modify it. But first, let me go ahead and clear some of this configuration off. So let's go to R20. And what I want to do is I want to know, is it possible for me to change my router ID? EIGRP event size, well, it's not under the topology. Is there a router ID config? Nope. So let's exit out of this. Let's go up one level. Let's say router ID, nope. What about EIGRP? There it is, router ID. So if I come up here and say router ID, what I'm going to do, just for the sake of argument, is I'm going to give it the same router ID as R22. So what I'll do is I'll come in here and I'll say the router ID is 172.16.223.222. And I'm going to hit enter. Okay, let's see if this is being used now. So show IP EIGRP topology, and it went ahead and did it on its own. Notice that the neighbor went down, route configuration changed, we have a new adjacency. So if I do show IP EIGRP topology table and hit enter and just scroll up, notice right here I have a router ID of 172.16.223.222. So now if I look at that default route, show IP route or show IP EIGRP topology table for 0000/0, notice now it tells me that it was originated on this device. So if I go over to R2 and take a look at it, exit, show, let's see, is it even here? Show IP route. Do I have a default route? Yes, I do. What's the nature of that default route? Well, it's an external prefix. It was advertised via EIGRP, and I'm learning it from 3 and from 2 on this device. So let's take a look at what's going on now. Let's say show IP route 00000/0. Nope, show IP EIGRP topology table. And again, tells me it was originated. Now, if I go over to R22, show IP route, show IP EIGRP, first of all, show IP route. Notice now it says my gateway of last resort is not set. So let's take a look at what's going on here. Say debug EIGRP packets terse. Now what I'm going to do is I'm going to wait, and I'm going to actually what I'll do is I'll go to R20 and I'm going to clear my connection. So I'm going to say clear IP EIGRP neighbors, and let's see if this forces an update like we would hope it would. And let's see what happens on R22. So we have updates going, null, enqueued. So we got a lot going on here. So let's take a look at show log. Show IP route 00000. It's not in my routing table. Show log pipe include. So all this is giving me is my update messages. This isn't going to show me what I wanted to be able to see. I wanted to be able to see the actual prefix information. So let's do this. Let's UAll this. Debug. And what I'm going to say is IP routing. Clear log. Let's go back over to R20 and clear the connection again. What I want to do is I want to see if I can illustrate where we run into this problem with regard to the prefixes that are being advertised to us and why we are not placing that particular prefix in our routing table. And so far I'm not even seeing it here, so let's see, show log, deleted. Since the route was never there, we don't see it leave. Show IP EIGRP topology table. See what we have here. And I really don't see any indication as to why it's not being placed in my routing table, UAll. So the question is there a show command that we can employ to be able to see exactly what's happening here? And what we want to do is I'm going to take a break and give you guys some time to think about that. And then what we'll do is we'll come back, we'll see if we can actually find one to use to be able to isolate the fact that we have a duplicate router ID in our EIGRP topology. In OSPF, it's a little easier to find than it is in the confines of EIGRP, but we'll figure it out and we'll do it in the next video. I'll see you guys there. Bye-bye.